27. A square field measures 10 meters by 10 meters. 10 students each mark off a randomly selected region of the field. Each region is a square and has side lengths of 1 meter, and no two regions overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface in each region. The results are shown in the table below. Which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface in the entire field? Right? So let's take a look at this. So is 10 meters by 10 meters for the entire field? Let me just go ahead and draw that. So it's 10 meters by 10 meters for the entire field. And each region is square and has side lengths of 1 meter, aka all these are divided into different regions like this, right? So there must be 10 1 meters and 10 1 meters here. So in this entire field, we've got 100 regions that we're looking at, right? Does that make sense? Because these little ones, right? These little ones are 1 by 1, right? Oh, that's not visible there. These little regions are 1 by 1, right? So we've got 100 regions here, and each region has roughly about, I don't know. Let's try to approximate the number, but I'm looking at the answer choices. And for A, B, C, and D, I all see 150. 150, 1,500, 15,000, 150,000. So I see the 1,5. And I'm looking at these numbers here, 107, 147, 146, 135, 149, 141, 150, 154. What's a good number that I can guesstimate for all these regions? There's roughly about 150 earthworms in each region. Does that make sense? Although you see all these different numbers, I'm just roughly estimating it to 150. The only reason being I'm looking at the answer choices and they all have 1,5 something. So each region has about 150. And the entire field's got 100 regions. 150 per region. We've got 100 regions. What do I do with them? 100 regions, right? And 150 per region. Just multiply, right? And the region gets canceled. So we have 150 and then 2 extra zeros. That many earthworms, roughly, in the entire field, which leads to my answer choice, C, 15,000. 28. If the system of inequalities y is greater than or equal to 2x plus 1 and y is greater than 1/2 x minus 1 is graphed in the xy plane above, which quadrant contains no solution to the system? So I hope everybody remembers how to draw the systems of inequalities on the xy plane. It's very simple. You just draw the same thing as what you would do in linear equation, except that there will be some coloring session here. So let's see what I mean by that. So let's just first take this, right, and just draw, right? Just draw as if it was y is equal to 2x plus 1. Just draw that, right? We all know how to draw a linear equation, right? So I'm just going to roughly estimate it just because we just need to see which quadrant it won't hit, right? So 2x plus 1. So y-intercept is 1 and the slope is 2. That's pretty steep. So something like that, right? So that's going to be this guy. And then let me draw the other one. Y is greater than 1/2 x minus 1. Remember, guys, if there's no equal sign, we draw a dotted line. I hope everybody remembers at least that, right? So I'm just going to draw as if it was y is equal to 1/2 x minus 1, right? So let me just mark that just for the sake of better to look at. All right, so for that one, y is greater than 1/2 x minus 1. So we start with minus 1 as y-intercept, which is down here. And then 1/2 x, 1/2 of slope, that's pretty flat-ish. So something like that. Oh, whoops. I meant to draw a dotted line. I just said it before, right? So dotted line. It really doesn't matter in this case, though, if you forgot the dotted line part. It really didn't matter in this problem. And now we are on to coloring. So what they mean by which quadrant contains no solution to the system, when I color both and any overlapping region is what we call system, the solution to the system. So let me draw what I mean by that. Y is greater than or equal to 2x plus 1. So I drew this line, but it says y is greater than that. So based on this line, I'm going to color above the top part, the top of the line. The reason being, it says y is greater. So anything above the line should be my solution for that specific line. And for this one, it also says y is greater. So anything above this line is going to be my solution. So something like that. Like that. So you guys see where the overlapping region is, right? Overlapping region is like right here, right? All this here, all that portion. That's all overlapping right there, right? Ugh, the coloring doesn't work. So that's all overlapping. Look at where it is hitting, right? It definitely hits quadrant 3 because this all portion here, that portion, that's definitely in quadrant 3. Quadrant 2 is definite, right? Like so much of the solution is in there. And here, there is a bit of solution over here where the overlapping occurs, right there. So it also does fall into quadrant 1 as well. But look at quadrant 4, the poor little quadrant 4. It's got nothing on them, right? Yeah, so it's got nothing on quadrant 4, which probably means the overlapping region all occurs at quadrant 3, quadrant 2, quadrant 1, but it doesn't occur in quadrant 4, which means there is no solution in quadrant 4, and therefore my answer choice is C. Number 29. For a polynomial p of x, the value of p of 3 is -2. Which of the following must be true about p of x? And you got all these answer choices. All right, this one does not look very familiar, right? It's like, what the hell does that mean by for polynomial p of x, the value of blah, 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 right? It's really confusing, but when I read the answer choices, it looks like something is a factor of p of x, like x minus 2, x plus 2, x minus 5, or something about remainder. So let's start from there, right? Let's think back to the factoring that we used to do, right? So let's think about some random polynomial, something like this, something like that, right? And then how do we usually solve this problem, right? Remembering back to Algebra 1, right? We usually set it equal to 0, and then we factor this guy out into x minus 4 and x minus 1, and then set it equal to 0, and then we solve separately, something like that, and we said x minus 4 is equal to 0, x minus 1 is equal to 0, and therefore x is 4 and x is 1. This is how we usually solve things, right? So if you guys remember this problem should be a joke, trust me, because take a look. We are saying x is equal to 4 is one of the solutions, right? And x is equal to 1 is another solution. Why is that? Because when we plug it in here, right, we got x minus 4 times x minus 1. So if x was 4, that would make it 4 minus 4 0, and 4 minus 1 3. So 0 times 3 will give you a 0. Same goes with this one. If x was 1, 1 minus 4 would be -3, and 1 minus 1 would be 0. So -3 times 0 would still be 0, right? So think about this. So I can say f of 4 for x is 0. And I can also say f of 1 for x, is also 0. Does that make sense? Now, taking that same logic onto this problem, let's see what it says. For a polynomial p of x, the value of p of 3 is -2. Forget the -2. Let's say p of 3 was 0. If p of 3 was 0, I don't know what p of x is, but something, it better have x minus 3 in there. If p of 3 was 0. Does that make sense? Because that's the same logic as what we did over here. We solved the x was 4 and x was 1 because we factored it out, and then we solve for those values. So when we plug it back in here, we should get a 0 because they are factors. The x minus 4 came from x, the x is equal to 4 came from x minus 4 is equal to 0, and the x is equal to 1 came from x minus 1 is equal to 0. So if p of 3 was 0, then that means x minus 3 should be a factor of p of x, whatever the p of x is. I don't know what p of x is, but it's not. In this problem, it's not, which should make my life a lot simpler, hopefully, because the fact that p of 3 is not 0, p of 3 is some other number, x minus 3 is not a factor, right? We know that for sure. So if p of x was divided by x minus 3, right, it shouldn't divide evenly because it's not a factor. Does that make sense? For example, what I mean by that is taking that here, the f of x, x squared minus 5x minus plus 4. When I divide that by x minus 4, it should divide nicely and give me something, which will give me x minus 1, of course, because the top one is x minus 4, x minus 1, and if I divide that by x minus 4, these guys should cancel, and that should leave me x minus 1. It divides nicely. Why? Because x minus 4 is one of the factors. But in this case, by realizing that p of 3 is not 0, p of 3 is something else, when p of x is divided by x minus 3, it shouldn't divide nicely, meaning it should give us some sort of a remainder. Because it doesn't divide nicely. Does that make sense? The definition of not dividing nicely means it will give you a remainder, right? So let's go through the choices and see what we can say for sure, because the question says which of the following must be true, right? A, x minus 5 is a factor of p of x. If I want to say x minus 5 is a factor of p of x, I should be able to say p of 5 is 0. Taking this logic over here, right? If I want to say A is true. But do we have this information in the question? Unfortunately, no, right? The value of p of 3 is negative 2. That's all we know. We don't have any information about p of 5. So I can't say A. B, x minus 2 is a factor of p of x. Once again, I should be able to say p of 2 is 0 if I want to say B is true, which I don't have information of in the question. So I can't say that. Same with C, right? If I want to say x plus 2 is a factor of p of x, I should say p of negative 2 is 0, which once again I don't have an information of in the question. Let's look at D, this guy. This suspicious, the longest guy. The remainder, when p of x is divided by x minus 3, is negative 2. Now, who knows what the remainder actually will come out to be, but what we know for sure is that p of 3 is negative 2, not 0, which means it's not a factor, which means that when it divides, it should give you a remainder. This one is saying the remainder will be there, which will be negative 2, which seems to be pretty logical when you divide the p of x by x minus 3 over here, x minus 3, p of 3. So the most logical answer that we can go with in this question is probably choice D. You don't have to know the details, the very details of this problem to answer the question, because for the sake of SAT, they don't expect you to have so much knowledge about such a question. If you just know that it's not going to divide nicely by x minus 3 and it will give you a remainder, that will be good enough to answer a question something like this. All right, number 30. Which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of vertex A, over there, can be identified as constants in the equation? So this problem is pretty much asking for what? A vertex form of the quadratic equation, right? So we have learned a few different forms of equations for this quadratic function, right? We have something called standard form, which I hope everybody remembers. Standard forms look something like ax squared plus bx plus c. That's a standard form. And I'll do the vertex form last. And we have an x-intercept form, right? Where it looks something like y is equal to x minus something and y minus x plus something, or x minus something. So it looks something like that. And then finally we have something called the vertex form, which is this one. Y is equal to ax minus h squared plus k. Now, for people who have trouble remembering this equation, this is what I give my students as a tip. You guys all remember the linear equation, right? Because that's relatively easier, and you've drawn millions of lines to memorize that, right? The linear equation looks something like this. Y is equal to mx plus b, right? If you know this, you should kind of be able to recall this vertex form for the parabola equation. Because take a look, it looks real similar. First of all, you have something called this y-intercept b. Instead of b, there's something called k in here. And instead of the slope here, they have something called a, which stands for amplitude, right? Which is pretty much the same thing, how steep your parabola will be, or how narrow or wide your parabola would be, right? And instead of an x, we have something called x minus h squared. Well, first of all, we have a square because it's a parabola, and we have an h because in parabola we have h and k, which stands for the center, or in this case, vertex, right? H and k is the vertex. Does that make sense? So let's now go back to the question. And the question wants which the coordinates of vertex A can be identified. So pretty much they want us to put this equation over here, what we see on top, into a vertex form, right? So any vertex form that is equivalent to this one, right? So first of all, what is vertex? That looks like 1 and negative 16-ish, right? So 1 and negative 16, I'm just going to say. And let's see which one has that. Well, first of all, look at your answer choices. If you were familiar with these three forms, you could have immediately gotten rid of choice A and choice B off the bat because they are x-intercept form, right? They have nothing to do with vertex form. These forms do not give you any idea of where the vertex would be, right? And C and D kind of looks like the vertex form, except this one is minus 15. Oh, that's probably going to be minus 15 as well. We'll see in a second, right? But the vertex form has h and k in it, versus this guy is x times x minus 2. So this is not perfectly in the vertex form, which probably means my answer choice will be D, but let's just make sure, right? This one will be x squared minus 2x minus 15. And this one will be x squared minus 2x plus 1 minus 16. So same thing, x squared minus 2x minus 15. So they are both the same, which is also equivalent to this over here as well. But I can get rid of this guy once again. The C is because where the x is in here, that should be the place where A should be there, the amplitude. Amplitude, just like slope, is some number. So it should look something like this. It should look something like this instead of having a variable in there like that, right? So my choice C is out. My answer choice for the correct answer is choice D. So if you were just familiar with the forms, this problem really should have taken you no more than 10 seconds. 31. Now we're on to the free response questions, right? How do you say that? Why can husk at least 12 dozen ears of corn per hour and at most 18 dozen ears of corn per hour? Based on this information, what is a possible amount of time in hours that it could take Wyatt to husk 72 dozen ears of corn? So let's think about the number, right? So if he, is it a he or she? I think it's a he. If he can knock down, if he can husk 18 dozen ears of corn per hour, that's the fastest he can do. And if he can husk NG. All right, number 31. Now we're on to free response questions. Wyatt can husk at least 12 dozen ears of corn per hour and at most 18 dozen ears of corn per hour. Based on this information, what is a possible amount of time in hours that it could take Wyatt to husk 72 dozen ears of corn? So let's think about the fastest and slowest that he can do, right? So slowest, fastest, right? So Wyatt can husk 18 dozen ears of corn per hour at most, right? So that's the fastest, right? 18 per hour. And then the slowest is at least, so 12 per hour. And then we're looking at 72 dozen ears of corn that he has to husk, right? So he's got 72 dozens to go, which means if he goes at the slowest rate, we will do 72 divided by 12, which will give him 6 hours to work on. And if he finishes the fastest, at the fastest rate, we will do 72 divided by 18, which will give you 4 hours, right? So it's asking for a possible amount of time, so just one possible amount of time. Well, at the fastest, he can finish it in 4 hours. At the slowest, he can finish it in 6 hours. So anything in between 4 hours and 6 hours should be your answer. So you could have put down 4 or 5 or 6 as your answer. Number 32. The posted weight limit for a covered wooden bridge in Pennsylvania is 6,000 pounds. A delivery truck that is carrying X identical boxes, each weighing 14 pounds, will pass over the bridge. If the combined weight of the empty delivery truck and its driver is 4,500 pounds, what is the maximum possible value for X that will keep the combined weight of the truck, driver, and boxes below the bridge's posted weight limit? Okay, so 6,000 pounds is the limit, right? Of which the empty, what was that, something about empty truck? Yeah, empty truck with the driver is 4,500 pounds. So let's first subtract that off, right? And that gives you 1,500 pounds to work with for all those boxes that you can carry, or the driver can carry, right? The truck can carry. And each box weighs 14 pounds, right? So we've got 14 pounds per box, right? Per box. And then the maximum we can fill at this point is 1,500 pounds. So what do we do with these numbers? Well, divide, right? 1,500 divided by 14, right? Which is not going to divide nicely, right? It's going to be, let's see, 6, 7. Yeah, it's going to be something close to 107-ish, because think about it. Well, the way I did this in my head as mental math is, well, 14 times 100 gives me 1,400, and then 14 times 7 gives me 98, which is 1,498. And you guys see how if I add one more box, so I go to 108 box, right? 108th box, then I'm going to pass over the limit of 1,500 pounds that we can work with, right? 1,498, we are like right there. We're not at 1,500 pounds yet, but if I add another 14-pound box in there, it's going to exceed the limit of 1,500 pounds that we can work with. And therefore, 107 boxes is the maximum that we can carry before we go over the limit. So the answer is 107. Number 33. According to the line graph above, the number of portable media players sold in 2008, I marked all these numbers for your reference, is what fraction of the numbers sold in 2011? Very easy question, right? 2008, so that's what we're looking at, 100 sold. And then 2011, that's also what we're looking at, 160 sold. And what are we asked? The numbers sold in 2008 is what fraction of the numbers sold in 2011, right? So 2008 is what fraction of 2011, right? So 100 is what fraction of 160? So 100 over 160, cancel the zeros. 10 over 16, simplify, 5 over 8, or 0.625 if you punch that into your calculator for decimal point. Very easy question. Number 34. A local television station sells time slots for programs in 30-minute intervals. If the station operates 24 hours per day, every day of the week, what is the total number of 30-minute time slots the station can sell for Tuesday and Wednesday? So, really easy, right? So Tuesday and Wednesday, we got 2 days, right? So 2 days worth of it. And every day is 24 hours, so 2 days must be 48 hours. And the television station can sell 30-minute time intervals, right? 30-minute intervals. So how many 30-minute intervals? So what is the total number of 30-minute time slots the station can sell, right? So in 48 hours, how many 30 minutes can fill? Well, every 2 30-minute, right, is 1 hour, right? So if it's 48 hours, we can fill 96 30-minute intervals. So what's my answer? 96. Super simple question, right? 35. A dairy farmer uses a storage silo that is in the shape of the right circular cylinder above. If the volume of the silo is 72 pi cubic yards, what is the diameter of the base of the cylinder in yards? So we are looking for what? The diameter. And you see how it's underlined? A lot of people will find a radius and just put that down as the answer. Please be careful. It's even underlined over there, right? So we're looking for this diameter, right? Okay, so first of all, we know the volume. So let's go ahead and find out the radius using the equation, right? So a lot of people try to remember, all these memorized formulas for the volumes and areas and surface areas for all these different shapes. For me, I just think of volume as big B times height. Area is also base times height, except it's a small b. And what does big B mean in this case? Big B is the area of the base. When we're talking about volume, since we're dealing with 3D image that is something like that, the big B stands for the area of the base. So take a look at this one. So let's just go ahead and fill it out. Radius we don't know, so we'll just call it R there. So volume of the cylinder, the right circular cylinder, should have been, once again, big B times height. Area of the base, the base is circle here, so area would be pi r squared, and then times the height. What do we know? We know the height, and we also know the volume, right? So the volume is 72 pi, and the height is 8. We know that, right? So pi r squared times 8. What can we do? We can divide by 8 pi on both sides to cancel out as many terms as possible. Cancel the pi, cancel the 8, right? And that gives me 9 is equal to r squared, so radius is 3. Now, once again, a lot of people are so excited at this point and just put down the answer as 3. You know what? I used to make those mistakes all the time, and believe me, it's not fun. Please, please read the question carefully. It says diameter, and it's even underlined. So if the radius is 3, your answer should be 6 for the diameter.